For this lesson, we're still working on the focus standard of Grade 8 Expressions and Equations, Topic A, Standard 1, Know and apply the properties of exponents to generate equivalent expressions. The topic for this video lesson is exponents, negative exponents. Our essential question is, how do we interpret and simplify values with negative exponents? Up until now, all of our examples have involved using exponents in the positive form. Now today we're going to explore exponents in the negative form. Take a moment to pause the video if you need to and copy down your header, set up your question column, and your note column, and resume the video when you're ready to begin. Before we can dive too much further into this lesson, we first need to look at what does this symbol here, and I'm purposely not using any words, what does it mean mathematically? So when you see this symbol, oftentimes the first response I get is, oh, that's a subtraction sign. So it means minus or subtraction. And that's the first way we're taught. As students progress and by the time they're getting up into 7th grade, I start hearing, oh, well, I also know that you put that sign in front of a value. It means that it's negative. Also correct. As we get into algebra concepts, we start to look at that sign and say, well, we could also say that it means these two things, but we could broaden that to say, well, that it means the opposite of. So throughout the year this year, we're going to use this symbol. When we see it, we're going to think of it in a few different ways. Minus, or subtraction, negative, or opposite of. So jot that down and be thinking about it because it's definitely going to help us with our work today. And just to make sure that we really believe that opposite of is one interpretation of that dash, that sign, we can take a look and realize that if we think about what is the opposite of addition and what is the opposite of positive, we come back to both of these examples, right? The opposite of addition is subtraction. So that takes care of our very first definition that we learned for that sign. And if we say the opposite of positive is negative, which would be true, then we get our second. So opposite of really is the umbrella definition for that sign. So, like I said, we're going to use this idea of this symbol, this dash, meaning opposite of, as we explore algebra concepts this year, and today as we explore negative exponents. So up until now, we have said that the exponent is telling us how many times to do what to the base. Well, we've been saying that it's how many times we multiply the base number. The exponent tells us how many times to multiply. So now, if we put this dash in front of an exponent, what is the opposite of multiplying the base? You said dividing, I agree with you. So negative exponents implies that we're going to divide because we're using the opposite of a positive exponent. Let's look at some examples. This one I've gone ahead and expanded all the way out, just to go ahead and show us. So 2 to the 4th, here our exponent of 4 is positive, tells us to multiply 2 by itself 4 times. So that means if we take 2 and use a negative 4 exponent, I don't want to just multiply by 2. I actually want to do repeated division. So I can take 1, put it in my numerator, and divide it by 2. That would be the first negative exponent. Multiply that by 1 divided by 2 again, and 1 divided by 2 again, and 1 divided by 2 again. I end up with 1 over 2 to the 4th. So positive 2 to the negative 4th exponent, or the negative 4th power, simplifies to be 1 over 2 to the 4th power. We're no longer just multiplying by that base number, we're dividing by that base number. Let's try some for you. So here's the next one. We have 3 to the third power. What would that tell us? Since our exponent is positive, we would repeatedly multiply our base number. And so it would look like this, 3 times 3 times 3. So what is it going to look like to take 3 to the negative third power? Well, we want to divide by our base. So whenever we're not sure and what our numerator should be and we want to divide, we just put a 1. And so we're going to divide by 3, our base number. And we're going to do that. We're going to do this 3 times. So it becomes 3 to the negative third power means 1/3 times 1/3 times 1/3. And that is equal to 1 over 3 to the third power. You're starting to get the hang of it? Let's try another one. Go ahead, pause the video here, and see if you can start with first what is 6 to the second power, and then use that to help you figure out what is 6 to the negative second power. So pause the video, do your work, and then resume the video to compare your work with mine. So if you said 6 to the second power is 6 times 6, then we would want to start interpreting 6 to the negative power as being 1 over 6 times 1 over, or 1 divided by 6, and doing that twice because it's a negative 2 exponent. 1 times 1 is still 1. And then we're still repeatedly multiplying this 6, so 6 is our base number in the denominator, and we're multiplying it 2 times. So 6 to the negative second power simplifies to be 1 over 6 to the second power. So what do you think? We've been using this strategy a lot in this unit. What do you think is the general rule for simplifying negative exponents? How do you go from 6 to the negative second power and jump right to knowing it's 1 over 6 to the second power? Or as it was in the case with our first example and our second example. Go ahead and jot down your thoughts so we can discuss them in class and add it to these rules for operations with exponents, and make sure that your header is fully complete, that you've copied all this down into your notes, and that you've left room for the summary so we can do more work with problems like this in class.